Okay, well, this is a much bigger crowd I was expecting to have, to be honest, so, all right. My name is Dr. John Wasson. I'm a researcher in the CATS, which is the Center for Automation Technology and Systems. My boss is John Wynn. He's one of the robotics people at RPI, and I'm a recent graduate. I got my PhD in December. So I'm here today to talk about a project called RoboRaconteur, which is something I've been working on for a couple of years now. This is not my primary research, but this is a kind of a piece I needed to finish my degree. So I'm actually here to recruit programmers for the summer. We have 3 positions open for URPs. So I'm just going to give you kind of an overview of the project and what we need the help for. So the motivation is that we have all these different devices floating around. They all have different protocols to talk to. It could be a library, ActiveX, COM, raw serial, raw TCP/IP, and they are a real pain to get to talk to each other. I can't tell you how many hours I spent trying to integrate different devices to talk to each other. So the design requirement is to create a peer-to-peer communication infrastructure, which will allow you to rapidly connect to devices. And what we really want is a system where we have a distributed multiple computers, but we have like MATLAB. You guys use MATLAB at all? Anybody? Okay, or Python or whatever. Any kind of high-level language where you have a bunch of devices on the table and you want to connect to them with a high-level language and start working with them immediately rather than spending hours writing interface code. So that's the goal of this program, is that basically they open up a port, you connect to it, and you can talk to it immediately. And it works pretty well, actually. And it's also designed so you can talk to it using a compiled language of C++ and get high performance. So there are a couple of different technologies out there. Some of you are probably familiar with some of these technologies. I've tried most of them. They've all failed miserably what I want to do. So that's why I gave up and wrote my own program. So as I said, it's designed for rapid communication. It's actually pretty fast. It can communicate a message in 300 microseconds, which is about the limit of network communication. And the way it works is it uses message passing between nodes and it serializes data. And as a client service model, so you have I guess really RPC or remoting unit or anything like that. Anybody? All right. So remoting is basically you have an object in one computer, you want to access from the other, so you create this layer between those 2 objects. And the idea is that the network becomes almost invisible in this system. This design is less overhead in the sense it doesn't try to do distributed process garbage collection or any of this fancy marshalling, because that just causes misery for different languages to try and talk to. So this is kind of a very simple idea of what the topology looks like. So you have a node with an endpoint and you have channels. And these endpoints are paired, so basically you create a pair of endpoints between nodes, and the channels communicate the messages back and forth. And these channels are pluggable. Right now they work for TCP/IP, Windows Pipe, and Serial. And we're going to try to expand that to some real-time and shared memory probably at some point. So a node can be a robot, can be a program. Here generally it's a program, so you have multiple programs on the same computer and each are a node. So that. This is a client service model. Basically the way it works is you have these objects on the server side you want to talk to on the client side. So basically you get this reference to these objects on the client side, and there's all this machinery which does the communication, which is RoboRaconteur. So the way it works is you have a service definition file which defines all the objects and the members. And the reason for this is that this is language neutral, so you can't say I'm going to write a C# based interface because it doesn't work in MATLAB or C++ or anything else. And it also does try-catch error transmission, which is extremely helpful when you have a complicated system. The use of message passing, this is really critical for what we're talking about now. So here's one of the projects we work on. This is the smart lighting. This is on the 7th floor. And basically what this does is RoboRaconteur provides a server which allows you to control the lights. This is a backlight unit. You can see it here. This is actually like a TV backlight, which is just blank for light. These wireless color sensors in the camera. So this is actually where RoboRaconteur really took off. Is that I wrote it for the other project I'll show you later. But once this became usable, they were actually using this from Minnesota to control the system, which I really hadn't expected. So anyway, so the architecture is that there's this program called RoboCamera Host and pluggable modules. And this is one of the pieces. It's not really This is kind of an extra piece of software I wrote for a different project, but it became useful. So basically what happens is in MATLAB you connect to the URL, and then the service returns a service definition file, and that's enough information for MATLAB to generate out all the interfaces. So you literally can talk to anything immediately without having to deal with any programming. This is what a service definition file looks like. You have the service name. Structures are like C structs, are just data, and objects are references. So you have properties, functions, events, sub-objects, and now pipes, which if you want to work in the project, you want more detail about that. It's fully object-oriented though. And that's saying you can connect from anywhere. I think he actually demoed this. This was presented in Italy last year. I think he actually connected from Italy and controlled the smart room. We also have the dual arm system. And I don't know if you guys heard about the congressional visit to the lab this August, but actually this robot was used for a demo where you can see how there's a Kinect on the head. This Kinect actually measured your motions and the robot would mirror your motions. So it was a really cool demo. And it uses RoboRaconteur for its communicating different modules. So as you can see, there's the Kinect, which is on a different computer. And then there is a MATLAB connection for a display, and then a RoboRaconteur connection to the motor man control software. I don't have a video. This is a PDF. Sorry. The other one is, this is actually one of the first systems I implemented RoboRaconteur on. This is a dual-arm robot system. So this is literally like across the room in size. These robots are about this tall. So there are 4 XPC target computers. It's an embedded industrial hardware system for MATLAB. There's got ATI force torque sensor, so it can detect and put pressure on it. And as you can see, the topology is a bit intense. All of these lines are RoboRaconteur communicating. So I tried to do this the first without RoboRaconteur, and it was really quite miserable. Once again, PDF. This is actually the research I did for my PhD. This is microassembly. And I don't think a video, which will make it kind of hard to see what it is. But anyway, so basically I'm trying to assemble microscopic parts. They're 300 micrometers by 25 micrometers in size. So this is the topology of this system. This is actually why I wrote the RoboRaconteur. So this computer here is my computer in my office with a window, and all of these are in a clean room. So actually one of the reasons I wrote this was so I wouldn't have to sit in a clean room for 10 hours a day. But so you can see all these different lines have this complex topology, and the thing is that all these MATLABs are for free. Basically, once you write the RoboRaconteur server side, you don't have to do any effort on the other side to make it work. Once again, PDF. This is another project. It's called ASOM. It's a steerable large field of view microscope. The use is called the formal mirror, which is an optical device it's a MEMS device where you can change shape dynamically. And then this is the architecture. This is the simpler one, to be honest. Actually, this is down to 300 microseconds now. TCP/IP is not really the best for automation because there's a lot of latency. I mean, who was doing the Bluetooth demonstration? You have a lot of latency in Bluetooth. And TCP/IP, if you have a gigabit connection, it's not too bad, but it's still there. So we're looking at stuff like real-time EtherCAT and stuff like that, EtherIP. So basically it's MATLAB Simulink, Arduino Linux. I'll explain the current. This is actually an older version. I'm almost releasing a new version of the software, which is more powerful. It's free and open source. It's on SourceForge. And here are the new features, which are pretty extensive. I don't really feel like going through them. But the truth is that we're going to be targeting lots and lots of platforms and lots of languages now. There's only so many I can do. The ones that bold are ones I have sort of done. But here's where the thing comes in. The current libraries are in C#, and that's mostly because that's what I need at the time, but that's not really ideal for a large project. So the goal of the summer project will be to convert all those to C++ in a more open source standard manner. And there are several challenges which make this difficult. One is there's no reflection. If you have an object in C# you can figure out what it is, you can't do that in C++. You just get a pointer with no detail. There's no built-in multi-threading support. There's Boost. I've never used it before. There's no garbage collection. You can use shared pointers, and that's kind of difficult. And multi-platform support is challenging in C++. In the current code base, there's a link on the website. That's the old version. This is the new the one I'm working on right now, which is almost ready for prime time. So right now everything it uses is Mono and .NET, which is not really ideal, but it's kind of where we are right now. So this is kind of my the reason it can work for me is that I have lots of robots. And this one is actually completely unused right now, so if you come work for me, you basically have this as a test bed for this project to do whatever you want with, basically. So, as I said, I'm looking for 3 programmers right now. If there's more, I'll see if I can figure out a way to compensate you. So yeah, just let me know, and as I said, I'll try to give you as much robot time as I can. It depends on the system and how dangerous or overutilized it is. So, any questions?
You seem to talk a lot about MATLAB. Do you need MATLAB in order to use this, or is this just one of the optional things that you can use to visualize?
MATLAB is very popular for this field. The strange thing about robotic engineers is they aren't really that good a programmer in general. So MATLAB is kind of the de facto standard for robotics. So one of the requirements just lined up for this project was MATLAB compatibility, and things have kind of grown from there.
So it's just compatible with it, but like if I wanted to write like a Python script to do everything, I could.
Yep. Well, here's the supported language goals. So there's C#, MATLAB, C++, Python, Java, Scilab, Octave, LabVIEW. I mean, on and on. As ambitious as we are, some of them we implement. I mean, right now we have it's sort of running on Linux and Mac OS. It really is currently running Windows, and next piece of target is the industrial computer use. But I also want to target Android, iOS, on Linux. So, like, if you want to come, play with an iPad, then sure, we'll figure that out. Yep.
I think you chatted with me last semester about the integration with RCOS.
I might have.
Yeah. Did you get that working ever?
No, that's still on the to-do list. To be honest, what happened was there was a set of features which were implemented, and it became obvious that I had to redo some stuff after a year or 2 of operation. So I've been working on trying to. I mean, first I had to graduate, so last semester was mainly just me finishing my PhD. So now this semester I've been trying to get this really up to where I want it. Oh, and the other thing is that this software may become the central or the standard light control system. So for next generation lighting systems, this is one of the projects where it could potentially become very significant in that field and in robotics too. So, anybody else? Okay, thanks.